I'm Anil Kumar. Welcome to all the students who want to practice quadratic equations test paper based on factoring applications. We have 6 questions here. I would like you to go through these 6 questions, pause the video, answer them, and then look into my suggestions. Now you should treat this as a real test paper of half an hour. So the first step here is to go through all the questions. So let's see. Here is question number 1. So broadly speaking, we are talking about a rectangle area and we have to factor to find its sides and dimensions. Question number 2 is about a projectile motion where a coin is thrown. H gives the height, and based on the equation, we have to find when does the coin hit the ground, at what time did the coin reach its maximum height, what is the maximum height of the coin reaches, find the height of the building, right? So these 4 questions relate to question number 2. And then we have question number 3, where you need to determine the value of k in the equation 4c square plus 12c plus k that will create a perfect square trinomial and provide reasoning. So there are communication marks for providing reasoning. Question number 4. Determine 2 values of b for the trinomial minus 3x square plus bx minus 75 to be factorable. Very interesting question. Now question number 5 and 6 are simple factor fully. We have 4 examples here and then 4 examples for question number 6. You can actually pause the video, even start from question number 6 if you want, right? So you can do in the reverse order also. These questions at the end are simpler as compared to the questions right in the beginning. I hope you have taken a note of all these questions, and now it's time to solve the test paper. So let's go through the solution of this test paper, taking question number 1 first. So let's begin. So as I solve, I will also explain. So I will take more time than what you should be taking. Question number 1. Area of a rectangle is given by the relation A equals to y square minus 11y plus 28. Provide an algebraic expression for the length and width of rectangle. So we need to factor this. Let's factor. So A equals to, you will do product and sum, right? So we are looking for a product of 2 numbers to be 28, and we are looking for sum of these numbers to be 11. So obviously the numbers should be both negative, and 7 and 4 work for us. And therefore we could write that the area in factored form should be equal to y is the variable, y minus 7 times y minus 4. Done? If y represents 10 centimeter, that is to say y equals to 10 centimeters. Determine the area of the rectangle along with actual dimensions. So that really means that we are talking about this rectangle, right? The sides are these factored sides, which are y minus 7 and y minus 4. So when y is 10, we have to provide the area and also these dimensions. You get an idea, right? So let's substitute 10 here. So we get 10 minus 7 times 10 minus 4. Now 10 minus 7 is 3 and 10 minus 4 is 6. The units are centimeters, so the area will be 18 centimeter square. And the dimensions will be 3 and 6. So it is very important to write these dimensions also, 6 centimeter and 3 centimeter. The area being 18 centimeter square. Is that clear? If you do all this, then you get full marks. Otherwise, you might just lose some. Now let's move on and take question number 2. Question number 2. Joseph is standing on the roof of a building. he throws a coin from his coin collection into the air and allows it to fall to the ground. The height of the coin over time can be modeled by the equation h equals to minus 5t square plus 12t plus 9, where h is height in meters and t is the time in seconds. When does the coin hit the ground? At what time did the coin reach its maximum height? What is the maximum height of the coin reaches? Find the height of the building. Now, let's begin with finding when it hits the ground. It hits the ground. At that time, height is 0, right? So it hits the ground. So let's substitute 0 for h, and we could rewrite this equation with negative outside and factor the rest. So we have 5t square minus 12t minus 9. It's good practice to factor the negative and then do the rest. Numbers do not have anything in common. Now, we're looking for product of 45 minus 45 and sum of minus 12. So we are looking for a product as minus 45 and the sum of minus 12. So the numbers are 15 and 3. 15 being negative, 3 being positive. So we could factor this. We'll factor it in 2 steps. So we could write this as 5t square minus 15t plus 3t minus 9. Do you see that? And then we can factor 5t from the first 2 terms. We get 3t minus 1. And taking out 3 from here, just t minus 3, sorry. 15 divided by 5 is minus 3. So taking out 3 from here, we get t minus 3 here. Now, t minus 3 is a common factor. So we get minus 5t plus 3 and t minus 3 as the other factor, right? So that gives you the factored form of the equation. So you could write as t minus 3 as a common factor and 5t plus 3 as the other factor. Now that gives you 2 values for t to be so that height is 0, right? So one of those valid values is when t equals to 3. So only at t equals to 3 we get height of 0. T cannot be negative, right? So we know t has to be greater than equal to 0. It cannot be negative. So at t equals to 3, this factor is 0. You see that part, right? So that is your solution. So when does the coin hit the ground? It hits at t equals to 3, units are seconds. Only then the height will be 0. Now, part B is, what time did the coin reach its maximum height? Now to find that time, we could do a couple of ways, but using factoring applications, it is the mid value of these two, right? So middle of these two values, which gives you 0, here you get 0 at t equals to minus 3 over 5. Correct? So that is one of your zeros. This is the other 0. So let's write them in decimals and find the center value. It'll be easier. So 3 divided by 5 is equal to 0.6. So this is minus 0.6. So the mid value here is minus 0.6 plus 3 divided by 2, right? So which is 2.4 divided by 2, which is 1.2. To get the maximum, we have to calculate height when t is 1.2. So substitute t with 1.2. So we get minus 5 times 1.2 square plus 12 times 1.2 plus 9. So that becomes the maximum height. So let's calculate this out. So we have negative 5 and within brackets 1.2 square plus 12 times 1.2 plus 9. So it's better to substitute these values in the original equation itself. The decimal equivalent value is 16.2 and the units are in meters, since the height is given in meters. Do you see that part? So that is how we find it. So basically what we did was, we had this parabola. So from the building, the coin came like this, right? So we knew that this time here is 3, and on the other side it was minus 0.6. So we found the middle value, which was 1.2, at which we found the height of 16.2 meters. So I hope this calculation is clear. So that answers B. At what time did the coin reach its maximum height? So time was t equals to 1.2 seconds. What is the maximum height? So maximum height h will be 16.2 meters. Do you see that? So 2 questions have been answered in doing these calculations. Now the last question here is, find the height of the building. So height of the building is when t equals to 0. So find h when t is 0. So it will be minus 5 times 0 plus 12 times 0 plus 9. So this 9 is the height of the building, correct? So we get this answer as equal to, height of the building is 9 meters, correct? So that is how you're going to answer this particular question. I hope all the steps are absolutely clear. Question number 3. Determine the value of k in 4c square plus 12c plus k that will create a perfect square trinomial. Explain your reasoning. So what is a perfect square? Let me write down a formula here. So a plus b whole square is equal to a square plus 2ab plus b square. So that is how the terms should be to make it a perfect square. What are we given? We are given 4c square plus 12c plus k. So our variable is c, right, in this case. So I could write 4c square as 2c whole square, correct? Now k could be written as square root of k and then whole square. And the center term should be 2 times these 2. So it is 2 times square root of k and 2c. But we are given the center term as 12c. So we get our equation. Do you understand? So 2 times 2 is 4. So we get 4c square root k should be equal to 12c. Do you see that part? So this 12c should be equal to that portion. So in this, c and c cancel and you get square root of k equals to 12 over 4, which is 3. So what is k equals to? Square both sides. So k equals to 3 square, which is 9. Do you get an idea? So that is how we are going to solve this question. So we get k equals to 9 as our answer. Very important question. Try to go through these steps and understand. Now question number 4. Question number 4. Determine 2 values of b for the trinomial minus 3x square plus bx minus 75 to be factorable. Very interesting question. I hope you got it. Let's look into it. So we need to factor minus 3x square plus bx minus 75. I'll prefer to factor out minus 3 and then try it out. So we get x square minus, the signs will change, b over 3x. This becomes plus, divide by 3 gives us 25. Now to make it factorable, we are looking for 2 numbers whose product should be 25. So what numbers could give product of 25, right? So for example, 5 times 5. Now when you add them up, then what do you get? You get 10. So that will give you one answer, right? So you could say that minus b by 3 should be equal to 10, and then cross multiply. B equals to, you can say minus b equals to 30 or b equals to minus 30. So that could be one combination, right? Okay. So you got one solution of b, which is b equals to minus 30. Now second combination, we could get 25 as 25 times 1. And when you add these, then you get this as 26, right? So in that case, you get minus b by 3 is equal to 26, correct? So plus 25, you could get 5 times 5 or 25 times 1. So when you add, you get this. So you get minus b equals to 26 times 3, which is 3 times 6, 18, and 1. 3 times 2, 6, and 1, 78. Or b equals to minus 78. So that is the other solution for you. So you could get these two values of b as your answer. Does it make sense to you? So that is how you could actually answer this question. I hope it makes sense. Now, let's move on to question number 5, which is simple factoring. So if you run out of time there, it will be tough here. So we are going to apply, in this case, product and sum. Correct? So looking for two numbers whose product is minus 20 and sum is minus 8. So one is positive, one is negative. Of course, we'll do x minus 10 times x plus 2. Correct? So these two numbers satisfy. Here we have minus. So first step is take minus common. All are even numbers. Take 2 also common. Then we get x squared plus 5x. Divide them all by minus 2 plus 4. Product of 4, sum of 5. So that means we have x plus 4 times x plus 1. That gives you the result, right? This is difference of squares. We could write this as 6x whole square minus 7 square. And now we can factor this as 6x plus 7 times 6x minus 7. Now here we have a quadratic equation where we want product to be 5 times 3 as 15, and the sum should be equal to 8. So the numbers are 5 and 3, right? That should give you sum of 8 and product of 15. So we'll split 8a. We'll write this as 5a squared plus 5a plus 3a plus 3. And that is equal to 5a common. We got a plus 1 plus 3 common, a plus 1. And now a plus 1 is common. We are left with 5a plus 3. So that is the factored form. Perfect. Let's move on to the last question. So I hope it was not very difficult. Now here we have slightly different kind of equation, rather expression. X minus 1 is a common factor. So we'll take x minus 1 and we are left with minus 5y plus 3z. That is the answer. Now we have 4 times minus 5. So we're looking for a product of minus 22, right? And the sum should be minus 8. So what are those numbers? This time the negative number has to be bigger, right? So minus 10 and 2 will work for us. So we'll write this as 4x squared minus 10x plus 2x minus 5. So we could take 2x common here. So we get 2x minus 5. And in this case, we cannot take anything common. So 1 is common, right? So 2x minus 5. So we have 2x minus 5 as one factor and 2x plus 1 as the other factor. Now, we could do group factoring. We can group them and then factor. We have 3 and a common. So we have x plus y. In this case, we have 2 common, x plus y, and so we could write x plus y times 3a plus 2. The last one here involves a perfect square. You could write 4a square as 2a whole square, 49 as 7 square. The center term is twice 7 times 2a, and therefore I could write this as 2a minus 7 whole square. Correct? So that's the end of our test paper. I hope you had very good practice. We had wide variety of questions dealing with factoring, and that gives you a balanced practice for your own test. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that will be great. Thanks for watching and all the best.